Alright, hi everybody. We are on our last video for this unit. We're on 8.6, sine and cosine of complementary angles, page 25 in your notes. So the opening exercise, I'm going to have you do this on your own, so you can pause the video in just a second. I want you to write the ratio of the sine and cosine of each angle as a fraction. And actually, I just want you to do one of them at first, and then we'll regroup together and talk. So I want you to do just these two first. So just fill in these two blanks. So go ahead and pause, try those out, and then we'll talk about what we find. So hopefully that's what you got. We had to be really careful because as you see, I was asking you to use Q as one reference angle and R as the other reference angle for the other question. So you had to actually switch around which was your adjacent and which was your opposite for each of these two questions. The hypotenuse stayed the same, but what we notice is that the sine of angle Q, the opposite divided by the hypotenuse, is 21 over 29, and the cosine of angle R, so once we switch to this reference angle, the cosine, the adjacent over the hypotenuse, is actually the same as the sine of angle Q. So what that tells us is, we have our right angle. We're never going to use that as our reference angle. But the other two angles, the sine of one of them is the same as the cosine of the other one. So what you don't have in front of you, unless you have your own calculator, is actually a way to find the measure of these angles. So what we'll do, as we've talked about, we'll do the inverse sine. So you don't have to write this. I know there's not a lot of room, but we'll do sine inverse of 21 over 29. And after I punch that into my calculator, rounding to the nearest degree, I get 46 degrees. So angle Q here is 46. Now we can actually use our knowledge of triangles to figure out exactly what angle R is. We can do 180 minus 90 minus 46. We can also find it using our trig function. So we can do inverse cosine of 21 over 29 to find angle R. And that measure actually comes out to be what we would expect it to be, 44 degrees. That's how we get this triangle to add up to 180. So the key to this lesson here is that these two angles are always going to be complementary. They always have to add up to 90 because we have one 90-degree angle here, so these two have to finish up to add to the rest of that 90. So if we look at sine of R, I want you to do these now, sine of R and cosine of Q. What we can predict is that the sine of one angle is going to be the same as the cosine of the other one. So we'll look at sine of R. Sine is opposite over hypotenuse. So the sine of angle R is 20 over 29. And the cosine of Q, cosine is actually adjacent over hypotenuse. That's also 20 over 29. So, it makes sense. The opposite of angle R, let me get out the magic pen here, the opposite of angle R, which is right here, is actually going to be the same as the adjacent of angle Q. So opposite over hypotenuse for R is the same as adjacent over hypotenuse for angle Q. And that's what we're going to kind of write down in a minute for a really important definition for today. So I guess what did we notice about the sines and cosines we found? We'll say that the sine of R is the same as the cosine of Q. That should be a Q, not a theta. There we go. So the sine of R is the same as the cosine of Q, and it works both ways. We know the sine of angle Q is the same as the cosine of angle R. And kind of the reason for this is that R and Q, sorry about that, R and Q are complementary, meaning they add up to 90. There's the other 90 degrees of our triangle. So let's look at one relationship that we know. So we're not going to fill in this whole thing. We know from that that activity we did in class that one day, we drew that 30-degree angle on our paper. We made sure we had a right angle, and every single one of you, no matter how big your triangle was, had a relationship of 1 over 2. Remember, we did the sine of 30. We did sine was 1 divided by 2, so that always came out to be 0.5. Every single time, you guys were all really close to that. Now, using our skills that we learned earlier in the year, we know this angle is 90. We know this is 30, so we can do 180 minus 90 minus 30 equals 60. So there's our complementary angles, okay? 60 plus 30, there's our complementary. So if I look at the sine of 30 and what we just learned above, now if I go down to the cosine of the complement of that, the cosine of 60, let's look back at our triangle. Cosine of 60 is adjacent over hypotenuse. So adjacent is 1, hypotenuse is 2, so that's actually going to be the same relationship. 1 over 2 is 0.5. And I wrote that on the wrong spot, didn't I? There we go. So that's the key. The sine of one angle is always going to be equal to the cosine of its complement. And that would work for all of these. So let's say we were looking at the sine of 10. The sine of 10 degrees, and if you have a calculator you can test this, is going to be equal to the cosine of 80. All right, so that's the big takeaway for today. Let's flip the next page. Let's skip this one. Here's our rule. So in a right triangle, if A and B are the acute angles, then every single time, no matter what, the sine of A will equal the cosine of B, and the cosine of A will equal the sine of B. So acute angles in a right triangle are complementary, therefore the sine of an angle is equal to the cosine of its complement, and the cosine of an angle is equal to the sine of its complement. So really what you're going to need to know, you can kind of skip through this, we may look at this in class the next day, but let's say I tell you that we're dealing, let's say the cosine of 70 equals the sine of x. Remember, these two angles are always going to add up to 90. So kind of what you can think of as 70 plus x equals 90. We can subtract 70 from both sides, so we know the complement of that angle is 20 degrees. So we know the cosine of 70 is always going to give you the same value as the sine of 20. Okay? So it all goes back to this first diagram. You know, if you forget your rule, you can always just draw this out, set up an example, and think about the true relationship there. So a couple other ways you'll see it is, let's look at, let's look at a couple of these real quick. So for number one, the sine of x equals the cosine of 63. To find out what x is, we just have to figure out what makes these two angles add up to 90. So this plus this has to equal 90. So we do a little bit of math. We subtract 63 from both sides, and we get x equals 27 degrees. There's your answer. So you can do the same thing for number 2. You can do the same thing for number 3. And now we'll have a couple of questions where we'll do it algebraically, but it's the same idea. We know these two things, these two terms, have to be complementary. They have to add up to 90. Because the cosine of one angle, there's angle 1, is always going to be equal to the cosine of its complement. So the sine of A is always going to equal the cosine of B. So here we'll just do 2x minus 1 plus 11 always has to add up to 90, and we'll solve for x. So your homework for tonight is to finish all the ones with a circle on it. So it probably won't take you that long. Do your best, and I'll see you next time in class.